All right, 78. The key to this problem is recognizing this as the definition of derivative. So just to refresh your memory, the definition of derivative is if I take a function and plug in x plus h and I subtract the function at x and divide by h and take the limit as h approaches to 0, you get f prime of x. So anything that resembles this is really going to be a derivative expression. So looking up here, the function involved is the natural log function. The value that I'm finding the derivative at is going to be e, right? F of e is 1, so that's why the 1 makes sense there. And so really this is the derivative of a function where the function is natural log x, and the value that you're finding the derivative at is e. So it's f prime of e, where f of x is the log function. A is our best answer. All right. 80. 80 is a question about concavity. We should think almost immediately of second derivative. So I'm going to go ahead and calculate the second derivative. Derivative cosine is minus sine. I've got a 2 out in front because of the chain rule. So it's negative 2 sine 2x plus 1 over 3x times 3. I'm going to go ahead and simplify that because I get just 1 over x for that term. All right, the second derivative is going to be the derivative of that. So I'm going to have a minus 4 cosine 2x. And the derivative of 1 over x is minus 1 over x squared. So that's my second derivative. The question is, when do you have a change in concavity? So I'm looking for when f double prime changes sign. And a lot of times, especially on the no calculator, you'd be expected to find the zeros, do the sign analysis, but with a complicated function like this, time for a graphing calculator. So I'm going to pull this in. I've already typed in the equation there. I'm going to look at the graph, and this is what I see. A little side note that the log function will only exist for positive numbers. So even though there's a second derivative that's negative, really the function doesn't exist, and therefore the second derivative doesn't exist until the right of 0. So I'm actually going to change my window to 0 to 10 instead. So this is what I see, and I'm looking for that first change in sign. Looks like it's going to be right here. Appears to be 1. I'm going to use the feature on my calculator to find it exactly. I've got to wait for it to draw here. So I'm going to do second calc 0 and try to find the point over here. And that should be my answer. 0.93. B is my answer for that one. All right, last question. Intermediate value theorem, not a super common question, but you want to understand what it says. I've got a function that passes through negative 3, negative 1. Also passes through 6, 3. And it's continuous throughout the interval. So there are a lot of possibilities here, but I know that there can't be any gaps or holes or asymptotes or anything like that. And the intermediate value theorem simply says if there's a y value between these two y values, 3 and negative 1, that there must be an x value between negative 3 and 6 that would produce that y value. So I'm looking for a statement that kind of says that. The last two are the only ones that really state that. So if f of c equals 1, that's a value between 3 and negative 1, for at least one value between x between negative 3 and 6. So D is what we want. That's our answer. Let's see why E doesn't make sense. It says there must be at least one value c that's equal to 0 between negative 1 and 3. So they picked an interval within the interval given, but you could imagine that there might be a graph that does this, right, that missed and didn't have a 0 in between there. So you want to use the values there, and it's basically if there's a y value between these two y values, then there must be an x between these two that produces that value.